So, good morning, everyone, and welcome to this lecture. This is lecture number 7 in current electricity. And in the previous lecture, what we had done in the previous lecture, I think we had seen the color coding. Do we remember this color coding of registers? We had seen this
Yes, sir.
color coding. Do we remember how to remember all these color codings? I told you the way to remember it. B.B. Roy of Great Britain had a very good wife. Do we remember that shortcut? So, we remember it? Yes or no?
Yes, sir.
Okay. Now, what I found in your exam of NEET that you can expect a question on this color coding. I've seen many times this question on color coding comes. So, I hope you can remember these color codes. The only thing that you have to understand is just remember these codes. If you don't remember these codes, you will not be able to solve it. So let me give you a question based on this color code, and I hope that you would be able to give me the answer. So this is a very simple question. You have to give me the color code. What will be the color code of this one? The question is draw color code for 52K. K means 1000. 52,000 kilo ohm plus minus 10%. Can you tell me what would be the color code of this? I'll give you 2 minutes to give me the answer. Silver color? I don't understand what you're saying. Okay. What is the color code for 4? What is the color code for 4?
Yellow.
So why yellow? What is the color code for 2?
Red.
Yellow, red. Kilo is 3. So what is the color code for 3?
Orange.
Orange. What is the color code for 10%?
Silver.
That is the answer. Yellow, red, orange, silver is the color code for this carbon register. Do we understand this? This is how
Yes,
you
sir.
get the color code. You should have given me this answer, bacha, not silver. Silver is just the tolerance level. Do we get this?
Yes, sir.
Yes, sir. Then, sir, this question, sir, coming on your screen, sir, and you will get 2 minutes, sir. You have this carbon register. You have to tell me what is the resistance of this register. You will get 2 minutes to do it. So that is the correct answer. You just have to go over the code. Yellow is 4, yes or no?
Yes, sir.
So 4. Violet, I think, is 7. So you have the first two numbers, 47 into 10 raised to the power. How much is brown?
Par 1.
1. 10 raised to the power 1. Then you come to the tolerance, plus or minus gold is 5%. So this is the answer for this one. 47 into 10 raised to the power 1, that is 470, plus or minus 5%. Everyone understands this? Yes or no? No, yes.
Yes, sir.
Well done. Then that brings us to the next topic, and the next topic is combination of registers. We have already done a bit of this in the chapter on capacitance. Do we remember this? Combination of resistance. We had done combination of capacitance. Do we remember it?
Yes, sir.
Same thing here. Nothing has changed. Same thing remains here. Now we have to do the combination of registers. What is the first combination that we are going to do?
Series.
The first combination that we are going to do is series combination. Everyone remember series combination? Yes or no? No, yes.
Yes, sir.
So, can anyone tell me? Yes, sir. What happens in series combination, bacha? What is same? What is different? Can anyone tell me? Ah, no one remembers it. You said yes, sir, but
Sir, series current remains constant.
so the series combination, my dear friends, is like this: three registers, four or two or five, whatever, combined in this fashion. This is the series combination. As you can see, current will flow from the uh, positive terminal towards the negative terminal. Yes or no?
Yes, sir.
Current is I. As you can see, current remains same. But if you talk about the voltage drop across this resistor is V1. The voltage drop across this resistor is V2, and the voltage drop across this resistor is V3. Voltage drop is different, so that is what you must remember. Point number one: current through the resistors is same, voltage drop V is different. Do we understand this? Yes or no? No, yes.
Yes, sir.
Now what I can do is I can replace these three registers and I can just put one resistor that is known as the equivalent resistance. Yes or no? No, yes.
Yes, sir.
R equivalent. And what is the value? And in this R equivalent, the same current will flow. Do we understand this?
Yes, sir.
Then you must know what is the value of this R equivalent. What is the value of this R equivalent in case of series registers? It will be R1 plus
1.
R2 plus R3. Yes or no?
Yes, sir.
Or you can simply write it is summation of Ri. The voltage drop across each resistor V1 will be equal to I into R1. V2 will be equal to I into R2. Will you understand this? There is only
Yes,
one
sir.
formula we have seen. V is equal to IR. And V3 is equal to I into R3. Also, we must understand that V1 plus V2 plus V3 will be how much? V1 plus V2 plus V3 will be how much?
IR1 plus IR2 plus I.
It will be equal
I.
to V. And this V will be equal to I into R equivalent. And therefore, R equivalent will be equal to R1 plus R2 plus R3 and so on. Do you understand this, everyone?
Yes, sir.
I'll give you 2 minutes to note this down. Let me know once you are done. Now, since we are on this series parallel combination, there is one thing also you must remember about resistors. In capacitors, we had seen that a capacitor stores energy in the form of electric field or electrical energy. How much was the energy stored in the capacitor? Does anyone remember? Capacitor has energy stored in it. How much was that energy stored in a capacitor? Anyone recollects? Anyone remembers? Boys, girls? Anyone remembers? What was the energy stored in the capacitor? Hmm? I'm waiting for answers.
Half,
Anyone, anyone remembers what was the energy stored in the capacitor?
half CV square, sir.
Half CV square was the energy stored. Capacitor stores energy. What about resistor? Does it store energy? Resistor cannot store energy. It's just a conductor. It's a, it cannot store energy, but it can develop power It can develop heat, it can develop power, or it can develop heat, or it can consume power. So here you can just write the power consumed by a register. Power consumed by a register. Power consumed by a register. Remember, it is power, it is not energy. So the power consumed by a register, and remember, this is going in the form of heat, delta H or delta Q. That power that the register consumes is I square into R. I is the current, I square into R. You can also write it as, you can write I as V by R, I as V by R. So you can write it as V square by R, or you can also write it as V into I, because V by R is nothing but I. So these are the three formulae that you can now make for power consumed, power eaten up, given to the register. Do we understand this? Yes or no?
Yes, sir.
This is power given in the form of heat. This is not heat energy, so let me not write delta H because you might get confused. You just simply write it as power. Now, if then they ask you how much is the energy consumed, how much is the energy given out in the form of heat, so then what you can do, you can write it as delta H, and that energy given in the form of heat will be power multiplied by time. So it will become I square R into T, where T is your time, or you can write it as V square by R into T, or you can write it as V I T. Everyone understands what we have written here? Yes or no? No, yes?
Yes, sir.
Now remember these formulae, and we will be using them. So now we will write a lot of notes on this, because these are the things that are going to come in your exam. Right now, you just write this, then I'll give you a couple of questions, and you will be able to understand what I mean by this. I will give you 2 minutes to note this down. Well, since you have noted this down, I've given you time. Let us move ahead and see what type of questions are we supposed to encounter in this one. And this is the first question that I am giving to you. Do it aram se. I have given you a circuit. It's a very simple circuit. There are three registers in this circuit. Now what you have to find out? You have to find out the current in each register, the voltage drop across each register, and the power developed across each register. Do we understand this? So these are all the questions that are put together. Do we understand this?
Yes, sir.
Current through each register, voltage across each register, power developed across each register. And once you understand this, things will become very simple. I'll give you 2 minutes to give me the answer. All the questions, all the parts. So I think you have done this. How are you supposed to solve this? The simplest way of solving this is, you can convert this you can convert this into a series combination. You can put it like this: one equivalent resistor. What will be the total resistance? 2 plus 3 plus 1,
6
6
ohm.
ohms. And this will be a battery of 30 volts. So straight away you can find out the value of current. Current is going to be same in all these. So what is the value of current that you will get?
5 ohm. 5 amperes.
You will get the current as 5 amperes. Everyone understands this? Yes or no? No, yes.
Yes, sir.
Okay. Now, once you get the value of current, then you can find out the other things. For example, what will be the voltage drop across this resistor? What will be the voltage drop across this resistor? Tell me, fatafat. What will be the voltage drop across this resistor? The only formula that we know is
6.
V is equal to IR. Yes. What will be the voltage drop across this resistor? Tell me, fatafat. Quickly. Yes.
Sir, 6.
Eh? 6? How did you get 6? V is equal to IR. 5 volt. Yes, Abhiram, that is correct. 5 volt. 5 ampere is the current. 1
Oh,
ohm is the resistance. So it is 5 volt. Not to worry. Can you tell me what is the potential drop across this resistor?
10 volts.
5 into 2, 10 volts is the answer. Can you now tell me what is the potential drop across this resistor?
15 volts.
15 volts. And as you can see, if you add 15 with 10 with 5, how much you will get?
30.
30. That is how things are done. So you add these three, you will get 30. Now let us move ahead and find out the power developed in all the three registers. What is the power developed in the first register, 1 ohm register?
25 watt.
So I square multiplied by R. So it will be 25 watt. Do we understand this?
Yes, sir.
What about the next one?
50 watts.
50 watt. I square into R. I square is same, just multiplied by R. First R is 1, second R is 2, and the third R is
75.
3, so 75 watt. Now if you add these three powers, 75 plus 50 plus 25, you will get
150.
the total power. And that is what you were telling me. Total power is
150.
150. You can also get the total power by multiplying I square by 6 ohms. So you add the power of the three resistors, you will get the total power. Do we understand this, or this has gone above our head saying bye bye? Bye bye.
Got it, sir.
Everyone got it?
Yes, sir.
Akka?
Yes, sir.
Confident? I can't see the confidence. Anyways, anyways, now give you a question which you might find in your examination hall. And this is the question. And I hope that I can get the answer for this question as simply as possible. So the question is like this. A bulb rating. Now, this is how bulbs are rated. Question number 2. A bulb rating is 100 watt. So basically 100 watt is the power and 220 volt. 220 volt is the potential difference, or on the line where you put this, that is the potential difference across the bulb. 220 volt. Then determine three things you have to determine. Number 1, the resistance of the filament. Every bulb has a filament. Number 2, current through the filament. Number 3, if a bulb is made to operate at 110 volt, what is the power consumed by the bulb? And you will have 2 minutes to give me the answer for this one. Remember, the only formula we know is power is I square R or V square by R. Everything comes from that. You have 2 minutes to give me the answer. Okay, now so let us go and solve this question. How are we supposed to solve this question? The power is given, the voltage is given. The first thing we have to find out is the resistance of the bulb. So I just put the formula of power. And which formula I choose? V square by R. Or I can write this formula as resistance of this bulb will be equal to V square divided by P. So the resistance of this bulb becomes 220, 220 square divided by power is 100 watt. That would be the resistance of this bulb. Everyone got this?
Oh, 484.
This is coming somewhere around 484 ohms. So that is your first answer. Everyone got this?
Yes, sir.
Then again I go to the same formula. Now I use power is equal to VI. Or I can write the current through the filament of the bulb is power divided by the voltage. That will give me the current. So current becomes power is 100, voltage is 220, and I think that is equal to 5 by 11. Yes or no?
Yes,
5
sir.
by 11 ampere. That becomes your current. Two simple things, we have done them. Now the only thing that is different is if the bulb is supposed to operate on 110 volt line. So from 220 I made it half. So basically we are going to see what effect does it have. Don't worry. Once you understand this, you will be able to get this. So how do I get this? So
Sir, power.
now to find power, again I use the same formula V square divided by R. The bulb is same, resistance is same. So the power it will develop is V square is 110 square divided by R. Instead of putting it as 484, let me put it by the original formula 220 square divided by R. So it gets, sorry, 220 square divided by 100. So 100 goes into the numerator and you will get this answer. You will get 1 by 4 and this power becomes 25 watts. So power becomes 1/4. Why does the power become 1/4? Because the voltage becomes half. Remember, power is directly proportional to voltage square. Voltage becomes half. Resistance is same. Voltage becomes half. Power becomes 1 by 4. Do we understand this? Yes or no? No, yes. Everyone understands this?
Yes, sir.
Great. Everyone got the answer for this one?
Yes, sir.
Okay. Now, what we can do is we can just write a concept and this will help us in solving some very lengthy problems very easily. Basically, what I written is division of voltage. What do you mean by division of voltage? Now, let us suppose that you have, and in most of the cases, you are going to have two resistance connected with a battery of voltage V, R1 and R2. Now, in this R1 and R2, you already know that the current is going to be same. Yes or no? Because they are in series. You understand that the current is going to be same,
Yes, sir.
but the voltage drop will be different. Let me call this voltage drop as V1 and let me call this voltage drop as V2. Voltage drops are going to be different. Now, the formula for finding out the voltage drop is you will find out the current and then you will multiply it by R1. You can just remember this. so that you can do the questions quickly. Voltage drop V1 will be equal to R1, the resistance, divided by R1 plus R2, and you just multiply this entire thing by the voltage V. Or basically what I mean to say is this voltage drop V1 is directly proportional to R1. Do we understand this? The resistor which has more resistance will have more potential drop. We understand this?
Yes, sir.
Similarly, you can write what will be the value of V2 on similar lines.
R2 by R1 plus R2 into V.
R2 by R1 plus R2 entire thing multiplied by V, or you can simply write V2 will be proportional to R2. Do we understand this, or this has gone above our head saying bye bye sir, I'm going sir, bye bye sir?
Understood, sir.
I will give you 2 minutes to note this down and remember it. One more thing you note down here, we have found out power here. We have also seen power here. Now power P1 will be I square into R1. So you can easily see that this power P1 across the resistor R1 is directly proportional to R1 because current is going to be same. Yes or no?
Yes, sir.
Similarly, power across the resistor 2 will be equal to I square into R2. From here, you can see that this power P2 is also directly proportional to R2. The resistor which will have more resistance will have more potential drop and will develop more power. Everyone understands this? I'll give you now 2 minutes to note it down. Since you have noted it down, I'll just give you a simple question based on the concept so that you can remember it. So, this is the question. So, I have this battery connected across two resistors. You just have to tell me what is the potential drop across each resistor. Sorry.
Sir,
Yes.
V1 is 4 volts and V2 is 8 volts.
V1 is 4 volt and V2 is 8 volt. That is absolutely correct. So how you got to do this? You can simply find V1 as 2 into 12 divided by 2 plus 4. Yes or no? Yes or no? R1 into V divided by R1 plus R2. So I think you will get 4 volt here to get the value of V2. You don't have to find the value of V2 now. Once you know that the voltage drop across this is 4 volt, the total voltage drop is 12 volt, this has to be 8 volt. So once you get one answer, there is no need to find out the other one. Do we understand this? Yes or no?
Yes, sir.
Well, that's what we call as series combination. In the next class, we'll go ahead with the parallel combination, put both of them together and see everything together. So that we will do in the next class, that is tomorrow. I hope you have understood what we have done in today's class, everyone.
Yes, sir.
Then we'll meet again tomorrow. Take care. God bless all of you. Bye bye.